So for the Chapter 1 activity, the first question asked what type of data these questions generated. The career community question was not on the big survey. I did have it in a mini survey, which I've since gotten rid of. So which of the following career communities do you belong to? And I had surveyed a class at one point, and these were the numbers of responses that people said. So I didn't have anyone in arts and communications taking statistics that term, but I had 7 people who were in this career community. And again, often people with computer science majors take other math classes. So there was 0, 0, 4, etc. But that data is qualitative or categorical, we could also say. The siblings question is quantitative discrete, and the age question is quantitative and continuous, because decimals are technically accurate for your age. Now for the frequency table, we can turn our results into a bar graph. My bar graph is not very fancy, but I put the icons for each career community at the bottom to make it easier so that you didn't have to write out all those words. And then on the vertical axis on the left, we have the word frequency. And I like to add in parentheses number of students, which I didn't put there, but I recommend you do that. So business and office professionals, or professions, professionals, and then social sciences, social services, and education, those are the 2 most popular categories. And we could add up and see 7 and 4 is 11. So it looks like we had 22 responses. So 7 out of 22. This question might be on the next page. That is the percentage. That gives us the percentage of people in that major, but we can't say an average. What percent of students are in the health, medical, and fitness career community? So again, do your part over whole, 4 out of 22. And when I do 2 divided by 11, or when I do 4 divided by 22, I get a decimal, 0.1818. So that's 18%. Here is the table for how many siblings do you have. And one of my frequencies was missing, like I alluded to in the slideshow. But since we have a total of 40 people taking the survey, we can figure out that this must be 6. Add these numbers up, subtract from 40, and you get 6. 6 people had 5 or more siblings. The relative frequency just takes the frequency and divide by n, the number of responses, and you get a decimal, and that could also be written as a percent. And then the cumulative relative frequency, I can't remember if this is actually important or not. Maybe it's going to show up somewhere. So cumulative just means that you add up all the categories up to this point. So this 0.40 means we added these 2 decimals together. 0.65 means we added these 3 decimals together. So cumulative means everything up until and including this category. So if we take all of these, add them together, we should get 0.83. So 83% of people had 3 or fewer siblings, is a way to interpret that. Because we rounded, we get a total of 1.01, but it really should just be 1.00, which is 100%. And I wouldn't worry about that. So the bar graph we had previously had categories on the horizontal axis. This graph has numbers on the horizontal axis, a number line with equally spaced values. And the bars are side by side and touching. So that's a requirement for a histogram. If we look back at this one, the bars had gaps between them. And that seems like a silly detail, but that's another thing that distinguishes a histogram from a bar graph. And finally, we can answer a couple more questions. 35% of students had 3 or more siblings. And the average number of siblings, this one's a little tricky. In order to get that answer, we have to add up all the data values, including the repetitions. And then we divide by 40. So I didn't really show you where I got the 89. But if we go back up here, again, very tedious, 0 plus 0, plus 1 plus 1 plus 1, 14 times, 2 10 times, 3 7 times, etc. So we can multiply 0 times 2, 1 times 14, 2 times 10, and add those up. And maybe I'll do that on a calculator right now. Okay, so I could sit here and go 0 plus 0 plus 1 plus 1 plus 1, but this is just going to be too annoying. So I'll do 0 times 2, which isn't even needed, 1 times 14 plus 2 times 10 plus 3 times 7 plus 4 times 1 plus, ooh, this is a little tricky, 5 or more times 6. And that gets me 89. And I'm feeling a little uncertain about this because I know that that was 5 or more, and I even remember there was somebody who had 9 siblings. If you had this table, you can't figure out what these responses might have been. So I just went with 5 times 6 and got 89. And then we take our 89 total and we divide by the 40 values that we had. So 89 divided by 40 gives me 2.225. So I could say that the average number of siblings is 2.2. And that's fine. I know you can't have 2.2 siblings, but you are allowed to have an average that has 1 decimal place more than the data values. So we will go with that answer.